What happened? Okay, so today we are going to start our next chapter, a new chapter, that is redox reaction, and redox reaction is from chapter 8. Okay, the chapter number is 8, redox reaction. So do you have any idea what is the redox reaction? Do you have any idea what is the redox reaction? Yes, boys, anyone have any idea what is the redox reaction? See, corrosion, right? Corrosion. Corrosion is a redox reaction. Corrosion is an example of a redox reaction. Yes or no? You have learned it in class 10, I think. In class 9 and 10 regarding corrosion. Yes, boys, please respond. Okay, corrosion. Corrosion, that is.
Yes, ma'am.
What is corrosion? Anyone have any idea? Say, what is corrosion? When metal are left in the atmosphere and metal oxide or some other compounds form a layer and metal is eaten up by that layer, that is actually known as corrosion. So corrosion of iron, that is rusting of iron. This is what? This is rusting. This is what? This is rusting of iron. Right. So actually, then if we consider photosynthesis, photosynthesis is also an example of an redox reaction. And if you consider any chemical reaction, each and every chemical reaction is a redox reaction. Redox means what? Redox means reduction plus oxidation. Okay, reduction plus oxidation. These two are simultaneous process. If reductions take place, then oxidation have to be take place, and the vice versa. If oxidation takes place, means reduction have to be take place. So each and every chemical reaction, is going to redox reaction. Each and every chemical reaction is going to redox reaction. Okay, understood? This is the redox reaction. So see, redox reaction. Okay, redox reaction. Redox reaction can be divided into two parts. One is oxidation and another is reduction. So what is an oxidation process? What is an oxidation? Oxidation we can say loss of electron. Okay, oxidation we can say loss of electron. Then gain of oxygen. Then gain of oxygen or electronegative atom. Or we can say loss of hydrogen or electropositive atom. So reduction is what? Reduction is just the opposite. Reduction will be just the opposite. Reduction will be gain of electron. Then loss of oxygen, or electronegative atom, and gain of hydrogen or electropositive atom. So this is the main basic idea of oxidation and reduction. Clear or not? Yes, boys. So oxidation is loss of electron or gain of oxygen or loss of hydrogen, whereas reduction will be gain of electron, loss of oxygen, or gain of hydrogen. Clear oxidation and reduction process?
Yes, ma'am.
Okay. Now, so what we have learned in junior classes, we have learned the classical idea of redox reaction. So let's see what is the classical idea. We just revise it once, so it will be easy for us to understand that whole process. So now we will learn the first thing, the classical idea of redox reaction. The classical idea of redox reaction. What do you think? What is the classical idea? What we have learned in junior classes? What is a redox? Redox reaction is what? Addition of oxygen. Redox reaction is what? Addition of oxygen.
Yes.
Redox reaction is addition of oxygen. Yes. Now let's see few examples. Let's see few examples. When suppose two magnesium react with oxygen, so it forms what? 2 magnesium oxide. Okay. 2 magnesium oxide, addition of oxygen, then carbon when react with oxygen, it forms carbon dioxide. It is a example of oxidation. When suppose sulfur react with oxygen, it forms sulfur dioxide, is an example of oxidation because oxygen is added. That's the example of oxidation. Let's take one more example, like CH4, that is methane, when react with water, sorry, not water, it will be reacting with oxygen, sorry. When methane react with oxygen, okay, it will form carbon dioxide, plus it will form water. So can you tell what is the oxidation process and what is the reduction process? So see, from methane to carbon dioxide, methane to carbon dioxide, oxygen is added, hydrogen is removing, right? Methane to carbon dioxide, this one, oxygen is added. So this reaction will be what? Oxidation, addition of oxygen, and from what? Oxygen to water, from oxygen to water, it will be reduction. Yes or no, boys?
Yes, ma'am.
Okay. Now, if I give you one more reaction, you'll do it by yourself and tell me the answer. When 2H2S reacting with water, it forms 2 sulfur plus 2H2O. Tell me the oxidation and reduction process. Tell me the oxidation and reduction process. Say. Anubhav, please try this one. Anubhav, are you listening to me? So here H2S is converted to H2S become converted to sulfur. That means removal of hydrogen. That means this process is oxidation. Whereas here oxygen is converted to water. That means hydrogen is added. So this process will be reduction. Clear? Very easy. Now tell me this one. Suppose when magnesium is reacting with fluorine. Fluorine is what? Fluorine is a very electronegative atom. Fluorine is very electronegative atom. When magnesium is reacting with fluorine, it forms MgF2. So this is oxidation because addition of electronegative atom. This is also oxidation because addition of electronegative atom. If we consider magnesium and react with chlorine and it forms MgCl2, this is also an example of oxidation because addition of electronegative atoms. Now tell me this one. 2K4 FeCN whole 6. Okay, when react with water, it forms 2K3 FeCN whole 6. Okay, plus 2 KOH. Can you try this one? See. Shubhan, can you try this one? Shubhan, Oititcho?
Yes, miss.
Shubhan, say. Biprodeep, any idea? Biprodeep, Devanna, any idea? See here, from, if we consider this reaction, see, here is K4, here is K3. That means what? Removal of electropositive ion, removal of electropositive atom from K4 to K3. It is what? Removal of
Miss, reduction.
Electropositive atom. Removal of electropositive atom means what? Loss of electropositive atom means what? See here. Loss of electropositive atom means oxidation. Okay. So loss of electropositive atom means oxidation. Whereas if we consider water to KOH, this reaction, addition of electropositive atom means reduction. Clear? Yes, boys, clear?
Yes, miss.
Okay. Now, just tell me, I'm just writing the reaction. You have to tell me oxidation and reduction process. Suppose H2S, okay, react with chlorine. It forms 2HCl plus sulfur. Tell me reduction and oxidation process, this one. See, H2S to HCl. H2S to HCl will be oxidation. And not sorry, this one. Sorry. H2S to sulfur. H2S to sulfur, removal of hydrogen. That means oxidation. And chlorine to HCl. This one will be reduction. Okay, yes or no?
Yes, miss.
Now
ma'am.
next is 3 Fe3O4 when react with aluminium, it forms Fe plus Al2O3. Tell me the oxidation and reduction process. Oxidation and reduction process.
Ma'am, from Fe3O4 to Fe, it is reduction, and from Al to Al2O.
Fe3O4 to Fe. That means removal of oxygen. Removal of oxygen is reduction. Yes, very good. Removal of oxygen is reduction. And from aluminium to Al2O3 will be
Oxidation.
oxidation. Very good. Very good. Now, next. When two sodium is reacting with hydrogen, so it forms what? 2 sodium hydride. Okay, 2 sodium hydride. So here the oxidation and reduction process. Here you have to remember that the electronegativity of hydrogen, is more than that of sodium. Okay, so that means if we consider this reaction, sodium to this one, so that means electronegative atom added. So electronegative atom added means what? Oxidation, and this one will be reduction, because electronegativity of hydrogen is more than that of sodium. Clear?
Yes, sir. Ma'am, have we finished up with the thermodynamics chapter?
No, I have not finished the thermodynamics chapter. Thermodynamics chapter we will do later. Who is asking?
No, Abhinava.
Okay. Now, redox reaction in terms of electron transfer. Now, next is redox reaction in terms of electrons transfer. So, see, at the beginning we have learned that loss of electron will be oxidation always, and gain of electron will be reduction. Okay, so let's see. Let's take one example. Suppose the example is like this: when 2 sodium is reacting with fluorine gas, it forms 2 NaCl. Okay, solid obviously. Now here Na to NaCl, what happened? Sodium, okay, it forms sodium plus, and it removes one electron. So that means removal of electron means what? Oxidation, and this is a half reaction. So that's why it is known as oxidation half reaction. This is known as oxidation half reaction. Now here Cl is formed, that means half Cl2 reacting with 1 chlorine, and it forms what? That means addition of chlorine means what? Reduction half reaction. Reduction half reaction. So if we add these two, then we'll get what? Sodium plus half Cl2 NaCl. This is actually the whole reaction. So that means if electron is removing, that will be oxidation. When electron is gaining, that will be reduction. Okay, let's take one more example. Like when 2 sodium react with half O2, okay, it forms Na2O. So if I consider 2 sodium, So 2 sodium, it forms what? 2 Na plus. For forming 2 Na plus, it have to remove 2 electron. It have to remove 2 electron. So that means this process is oxidation. And half O2 will gain 2 electron and it forms O2 minus. It forms O2 minus, half O2 will gain 2 electron and form O2 minus, and that process will be reduction. And it forms Na2O like this. Clear what is oxidation and reduction?
Yes, miss.
Now, one more very important topic, that will be oxidizing agent and reducing agent. Very important. Oxidizing agents and reducing agent. So what is oxidizing agent?
The substances which undergo reduction.
Yeah, that means that's oxidizing agent means which oxidizes other and gets reduced itself, right? Okay, oxidizes others and gets reduced. Okay, that means what? Easily gain electron. Easily gain electron. Yes, easily gain electron, oxidizing agent. Whereas reducing agent will be just the opposite. Reducing agent will be just the opposite. Reduces others. Okay. And gets oxidized. Reduces others and gets oxidized. And what? Easily loses oxygen. Easily loses electron. Sorry, easily loses electron. Okay. So oxidizing agent is oxidize others, get reduced itself, and easily gain electron. Whereas reducing agents are reduces other, gets oxidized itself, and easily loses electron. Clear? It will gain electron easily. Oxidizing agent gain electron easily. Reducing agent will lose electron easily. Okay. Just I'm giving you one example, like when sodium is reacting with half O2, it forms Na2O. So here sodium are easily loses electron, so will be reducing agent. And oxygen will be oxidizing agent. Clear? Yes, boys, clear or not? Yes, boys, please respond. Clear or not?
Yes, ma'am.